Sample spaces. Sample space is the set of all possible outcomes. For example, the number observed when a die is rolled. The sample space is 1, 2, 3, 4, 5, and 6. The set of all possible outcomes is called sample space for the experiment. For the example, the sample space when the two coins are tossed. The sample space is head, 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 tail, tail, head, and tail, tail. An event is a subset of the sample space. For example, the sample space of a die is rolled is 1, 2, 3, 4, 5, 6, and the event is subset of 1, 2, 3, 4, 5, 6. For example, an odd number is 1, 3, 5 from the die is rolled. Another example is when the two coins are tossed. The sample space are head, 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 tail, tail, head, and tail, tail. The event, two tails, tail, tail. Determining probabilities for the equally likely outcomes. For example, a dice is thrown once. What is the probability of getting a multiple 2? Sample space of a dice is sample space is for a die is 1, 2, 3, 4, 5, 6, and then multiple of 2, the event is multiple of 2 is 2, 4, and 6. So the probability is 1, 2, 3 over 6. So the probability is 1/2 or 0.5. If one card is drawn from a well-shuffled pack 52 cards, then what is the probability of getting either a red 6 or a red 8? There are two red of 6 heart and 6 diamond, and also there are two red 8 diamond and 8 heart. So there are 4. The probability is there are 4 over 52 cards equal 1 over 13. If two coins are tossed, then find the probability of getting 2 tails. The sample space of 2 coins is head, 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 tail, tail, head, and tail, tail. Find the probability of getting 2 tails. So the probability is 1 over 4. Only 2 tails there, and over the sample space 4. So 1 over 4. A card is drawn at random from a pack of 52 cards. What is the probability that the card is A, not a king, B, not a black? There are 4 king, spade, heart, diamond, and club. So it's not a king is mean the probability is not a king. 52 minus 4 over the sample space 52. So 48 over 52 equal 12 over 13. For B, not a black, it means red. Red, there's 26 red card over sample space 52. It means 1 over 2, 1/2. Answer the following for a normal deck of playing cards. How many cards are there? There are 52. How many suites are there? There are 4. What are suites called? Heart, diamond, spade, clover or club. Clover or club. Which suite are red and which suite are black? The red one is heart and diamond. Heart and diamond. Heart and diamond is red. So heart and diamond is red. And spade and club are black. How many cards are there in every suite? There are 13 cards every suite. Which cards are known as the picture card? Picture card is ace, king, jack. So I write here for number F, ace, king, jack, and queen. How many aces are there in the deck? There are 4 aces. Heart ace, diamond ace, spade ace, and club ace. How many picture cards are there in the decks? Ace, there are 4 aces, there are 4 king, there are 4 jack, and there are 4 queen. So it's 4 times 4, 16. A card is drawn at random from a well-shuffled pack of 52 cards. Find the probability that the card is a club. Club is like this. The picture of club is a club. There are 13 cards of club. So 13, probability is 13 over 52. So it means 1 over 4. For number B, find the probability, for letter B, find the probability that the card is a red. There are 26 red cards over sample space 52, so it's 1/2. A picture card, ace, king, queen, and jack. Every card of ace is there are 4, king there are 4, queen there are 4, jack there are 4, so over total is 4 times 4, 16. 16 over 52 equal 4 over 13. A red picture card. There are 2 ace, red ace, there are 2 red king, there are 2 red queen, and there are 2 red jack. So total is 2 times 4 is 8. 8 over 52. So equal 2 over 13. A number is drawn at random from the set 1, 2, 3 until 20. What is the probability that the number is divisible by 2? This divisible by 2 is, the number is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. There are 10 numbers. 10 numbers over sample space 20, so it's 1 over 2, 1/2. Divisible by 3. The number can be 3, 6, 9, 12, 15, 18. There are 6 numbers. 6 over 20. So the answer is 3 over 10. Divisible by both 2 and 3. Number divisible by both 2 and 3 is 6, 12, and 18. So divisible by both, the probability is 3 over 20. Consider the following spinners. In each case, what is the chance of the pointer stopping in region 1? Letter A, you see region 1 is 1/3 of the all region. There's a 3 region, 1 is 1, so the probability is 1 over 3, 1/3. For letter B, the probability of 1 is 1 over 8. For letter C, 1 is only 1/4 of the total area, 1/4 of the total area. So the probability of region 1 is 1/4. A square of a side length 1 meter contains a blue 1/4 of a circular disc centered at the bottom left vertex of the square. What proportion of the square is blue? If a dot thrown at the square is equally likely to hit any part of the square, and it hit the square every time, find the probability of hitting the blue region. Okay, it's on 1 meter. The side is 1 meter. It's 1 meter. The blue side, the area of the blue side, 1/4. The area of the 1/4 of the circle. So pi times r square. The r is 1 meter. So 1/4 times pi times 1 square. So the area is the blue region is 1/4 meter square. For B, find the probability a dot is hitting the blue region. So the area of blue, 1/4 meter square, 1/4 pi meter square over the area of the square. Area of the square is 1 times 1 meter square of the sample space. The area of the square is 1 meter square. So the probability hit the blue region is 1/4 pi, or 1/4 times 3.14 equal 0.785. A dot is thrown at random onto a board that has the shape of a circle as shown. Calculate the probability that the dot will hit the shaded region. First, we find the area, the small circle. So an area, small circle. A1, small circle. Pi r square. The pi is 22/7. R is 7 square, So the answer is 154 cm square. And then find the area, the big circle. Pi r square (22/7). The r is 14 square, 616 cm square. This on the sample space. The shaded area is the bigger, so the big circle minus small size circle. 616 minus 154, 462 cm square. So the probability the dot will hit the shaded area, the even 462 over the sample space 616. So equal 3/4 equal 0.75. A spinner is as shown in the diagram. Find the probability that when spun the pointer will land on A, red section, B, yellow section, C, any section except the yellow section. The red section is 120 over total the degree of the circle 360. So the red section, the probability the dot will land on the red section is 1/3. For yellow section is 60 over sample space 360. So it's 1/6. Any section except the yellow, it means the green and the red. So any section except yellow is green and red. 180 plus 120 is 300 over 360. (5/6). Two regular dice are rolled. Use the sample space for this experiment to find the probability that the sum of the number is showing is A equal to 10, B odd, C less than or equal to 7. The sum equal to 10 is this one, and this one. So there are 3 over 36. So 1/12. 1/12. Odd number there is half than the sample space. So 18 over 36, so equal 1/2. Less than or equal 7. Less than or equal 7. This one, the sum is less than or equal 7. This one. Less than or equal 7. There are 21 over 36 equal 7 over 12. A fair coin is tossed 3 times. Use the sample space for the experiment to find the probability that A. Exactly 1 tail is observed. B. Exactly 2 tails are observed. C. Exactly 3 tails are observed. D. No tail are observed. We make a sample space. So H, this one's tail here. H, tail, H, tail, H, tail, H, tail, head, tail, head, tail. So head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. Number A, letter A. Exactly 1 tail observed. 1 tail observed. 1 tail observed is here. 1, 2, 3. So 3 over 8. 3 over 8. Exactly 2 tail observed. 2 tail observed. 1, 2, 3. Also 3 over 8. For C, letter C, 3 tail observed. 3 tail, only 1. So 1 over 8. Over 8. For letter D, no tail observed, no tail. So only 1, no tail observed, only 1. So 1 over 8 also. Okay, for example, S is 1, 2, 3, 4, 5, 6, and 7. S is the universal. Member A is 2, 3, 5, and 7, and B is 1, 3, 5, 7. The union, if A union with B, so we combine A and B, 1, 2, 3, 5, 7. If A intersect with B, find the same one, 3 and 5. 3 and 5 and 7. Because they are same here, 3, 5, 7 are same. So the intersects, we find the same number from A and B. If A complement, so we find the member outside the A is 1, 4, and 6. If B complement, find outside the B is 2, 4, and 6. Let E epsilon 1, 2, 3, 4, 5, 6, where the outcomes are equally likely if A 2, 4, 6 and B is 3, find probability A union B. For A union B is 2, 3, 4, 6. So the probability is there are 4, 1, 2, 3, 4 over sample space 6. So 2/3. For A intersect with B, or we can find any number there, intersect, there is no same number, so the probability equal 0. A complement is 1, 3, 5 outside the A, so the probability is, for number C is 3 over sample space. There are 6 sample space here, over 6, so 1/2. Now is B complement. Complement is 1, 2, 4, 5, 6, except member of B. So the answer is 5 over sample space is 6. So the answer is suppose that in a certain school, the probability that a student plays soccer is 0.18, the probability that a student plays tennis is 0.35, and the probability that a student plays both soccer and tennis is 0.11. Find the probability that the student play either or both of these sports. Probability is play soccer. If A is soccer, 0.18. Play tennis, B is tennis. (0.25). Play both soccer and tennis. (0.11). So, find the probability that a student play either or both of the sport. So they're asking union. So equal 0.18 plus 0.25 minus 0.11. The answer is 0.32. Or we can use this one answer, or we can use the Venn diagram. Make it bigger. This Venn diagram. This one A, this is B. This one A is soccer, B is tennis. This one 0.18 0.18 minus 0.11 is 0.0.0 0.07. 0.25 minus 0.11 is 0.14. 0.14. And we plus it all. 0.07, 0.07, 0.07 plus 0.11 plus 0.14 equal 0.32. The answer is same. You're using the Venn diagram or using the formula. Suppose that in a certain school, the probability that students study Chinese is 0.22. The probability that students studies French is 0.35, and probability that students study both languages is 0.14. A. Find the probability that student that in that school studies at least one of these languages. B. Find the probability that a student in that school studies exactly one of these languages. For number A, you can use formula. If you want, use formula P A union B equal PA plus PB minus PA intersect with B. Or you can use the diagram, Venn diagram. I will use Venn diagram. A is for Chinese, B is for France. For France, study both is 0.14, 0.14, 0.14. Study Chinese 0.22, 0.22 minus 0.14 is 0.8. Studies France 0.35 minus 0.14 is 0.21. So for A, student studied, find probability the student in that school studied at least one of these languages, at least. So 0.8 plus 0.14 plus 0.21 equal 0.43. For B, find the probability that student in the school studies exactly one of these languages. 0.8 plus 0.21 equal 0.29. Probability tables. It's a row 1, row 2, and row 3, and then column 1, column 2, and column 3. Here this one is A intersect with B. This one is A intersect with B complement. Here A complement intersect with B. Here is probability of A complement intersect with B complement. This one is total probability of B. This one is total, the sum of probability of B complement. This one is the sum of probability A. This one sum of probability A complement. And total of sum of all probability is 1, equal 1. A book is chosen at random from a bookshop. It is known that this is a bookshop. The probability that the book is hardback but not is novel is 0.05. The probability that the book is not hardback but it's a novel is 0.12. The probability that the book is not a novel is 0.19. Find the probability that the randomly chosen book is A. a novel, B. a hardback novel, C. a hardback, D. a novel or hardback. I put here 8 is hardback. This one is hardback complement. So novel complement. The probability the book is hardback but not a novel is 0.05. 0.05. The probability that the book is not hardback but is a novel is 0.12. The probability that the book is not a novel is 0.19. So make another table here. Total probability is 1. And then I try to find another number. Zero 0.19 minus 0.05 is 0.14. Zero 0.12 plus 0.14 equals 0.26. 1 minus 0.19 is 0.81. 0.81 minus 0.12 is 0.69. 0.69 plus 0.5 is 0.74. Question A. Find the probability the randomly chosen book is a novel. So novel is 0.81. B. Hardback novel is mean intersect hardback and novel. This is probability of novel, so it's 0.81. B is a hardback novel. Hardback intersect with novel. Hardback intersect with novel equal 0.69. For C, a hardback is 0, so it is hardback is 0.74. For letter D, a novel or hardback, probability novel or hardback union. So for D is novel and hardback is union. So the formula is novel is 0.81. 0.81 plus hardback is 0.74 minus the intersect 0.69. The answer is 0.86. For D, remember the formula. For D, remember the formula is if P A union B equal probability A plus probability B minus probability A intersect with B. So we did for letter D. So the answer is for a novel is 0.81. For hardback novel is 0.69. For a hardback is 0.74. And for a novel or a hardback is 0.86. At a school camp consisting of 60 students, sailing was offered as an activity one morning and bus walking in the afternoon. Every student attended at least one activity. If 32 students went sailing and 40 students went bus walking, find the probability that students chosen at random A undertook neither of these activities, B has sailed or bus walk, C has sailed and bus walk, D has sailed but not bus walk. Okay, B is S is sailing. S complement is not selling. Not selling is S complement. B is bus walking. B complement is mean not bus walking. The total is 60 students. 32 students went sailing. 40 students went bus walking. Every student attended at least one activity, at least, so there's no one is not joining, so at least one student choose one activity, so this one is 0 here. Zero. $60 minus 40 is 20. 60 minus 32 is 28. 28 minus 0 is 28. 20 minus 0 is 20. 40 minus 28 is 12. Undertook neither of this activity, so it's 0. Because everyone is took at least one activity. Has sailed or bus walk. Probability is A union B. Has sailed or bus walk. 40. This one is a probability. Remember, this one probability is A. B equal probability A plus probability B minus probability A intersect with B. So it's 40 plus 32 minus 12 over the sample space over 60. So equal 1. So A is on B. For C, has sailed and bus walk. Sail and bus walk, probability is this one, 12 over 60, so 1 over 5. Letter D, has sailed but not bus walk. Has sailed but not bus walk is this one. So its D is 20 over 60. 1 over 3, 1/3. The probability of event A occurring when it is known that some event B has occurred is called conditional probability. It's written P probability A given B can be thought as a means of adjusting probability in the light of new information. The conditional probability of event A given that event B has already occurred is given by probability A given B equal probability A intersects B over probability B, and probability B is not equal 0. This formula may be arranged to give multiplication rule of the probability A intersect B equal probability of A given B multiplied by probability B. The law of total probability states that in the case of two events A and B, probability of A equal probability of A given B, probability B plus probability A given B complement multiplied by probability B complement. A group of 500 students were asked whether they would rather spend their recreational time playing sport or listening to music. The result, as well as the sex of the student, are given in the table. One student is selected at random from these 500. Find A, the probability that student prefers sport, B, the probability that student prefers sport given that they are male. So A, the question is asking probability student prefers sport is 375. Over 500 students, so equal for A 3/4. For B, the probability that student prefer sport given that they are male. So male occur first. It happen first, occur first. So male and sport here. 225. Over 500 equal 9/20. In a class of 28 students, there are 15 girls. It means there are 13 boys. Of the students in the class, 6 girls and 8 boys play basketball. A student is chosen at random from the class. If G represents the event that a girl student is chosen, and B represents the event that student chosen play basketball. Find probability of G, find probability of B, find probability of B complement, find probability B given G, probability of G given B, probability B given G complement, probability B complement intersect with G complement, probability B intersect with G. The first, I will try to make a table. A table here, table here. Okay. This one boy, this one's a girl. I make a small b. Yes, so it's a small b is boy, small g is girl. This one basketball. This one is not basketball. Girl, there's 15 girl and 13 boy. Total is 28. 6 girl play basketball and 8 boy play basketball. So total is 14. 13 minus 8 is 5. 15 minus 6 is 9. 5 plus 9 is equal 14. So probability G is represents the event. G represents the event of the girl student is chosen. Girl is chosen. Girl, how many girl? There's 15 girl. 15 over 28. For B, probability is B represents the event that students choose play basketball. There are 14 students play basketball. 14 over 28 equal 1/2. For C, probability is B complement. B complement is mean a boy. Sorry, B complement is mean student not choose play basketball. Student not choose play basketball is 14 student not choose for basketball. 14 student. 14 student not choose for basketball. So it's 14 over 28. 1/2 for C. Now for D, probability of B given G is given. So for D, the formula is B given G equal probability B intersect with G over probability G. So for D equal, is this part I put here, so it's 6 over probability G over 15. 6 over 15. So for D is 6 over 15. Okay, I will make it smaller. (15 over 28). B is 1/2. 28. B is 1/2. And C is also 1/2. 1/2. D equal 6 over 15. Now E. Probability of E probability of G B is given. This probability G over probability B. B and G 6 over probability B is 14. B is play basketball. So 6 over 14. 3 over 7. So it says 3 over 7. Now for F. Probability of B G complement is given. G complement over probability of G complement equal 8 over 13. 8 over 13. Now for letter G. For letter G, probability B complement and G complement. B complement and G complement is this part, the 5 over 28. And for H, 5 over 28. Then for H, probabilities for H, probability B and G intersect are 6 over 28 equal 3 over 14. The probability of an event A occurring when it is known that some event B has already occurred is called conditional probability, and is written probability of A given B, where probability A given B equal probability A intersect B over probability B, if probability B is not equal 0. Two events A and B are independent if the occurrence of one event has no effect on the probability of the occurrence of the others. That is, if probability of A given B equal probability A. Even A and B are independent if and only if probability A intersect B equal probability A multiplied by probability B. A group of 500 students were asked whether they would rather spend their recreational time playing sport or listening to music. The result as well as the sex of the student are given in the following tables. Is preference for playing sport or listening to music independent of sex? We check it, this one independent or not. Okay, the first is a male intersect with spot, equal 225 over total of people is 500, this means 0.45. Probability of male (300 over 500). Probability of spot is 375 over 500. Independent if the condition, if the condition of if independent multiplied by B. So we'll check it. Is correct or not? So it's an equal here. Should be this one. 0.45 equal this one multiplied by this one. So it's 0.45 equal 0. This one times this one is 0.45. So it means this event is a independent event because the condition is correct. Because probability is male intersect with spot equal probability male multiplied by probability of spot. The probability that a married woman watches a certain television show is 0.4, and the probability that her husband watches the show is 0.5. The television viewing habit of the husband and wife are clearly not independent. In fact, the probability that a married woman watches the show given that her husband does is 0.7. Find the probability that A. Both the husband and wife watch the show. B. The husband watches the show given that his wife watches it. Okay, now A. What is known here is probability the wife watching is 0.4. The husband watching is 0.5. Probabilities of wife and husband is given is 0.7. A, asking about probability of wife and husband watch the show equal probability of wife husband is given time probability of husband 0.7 multiplied by 0.5 equal 0.35. So the answer for A is 0.35. For B, For letter B, the husband watches the show given that his wife watches it. Probability of husband given wife watches it equal probability of wife intersect with husband over probability of wife equal, this one is 0.35, we found it from question A, over wife is 0.4, so equal 0.875 for letter B.